Yeah, thanks for the introduction. I'm Takuro Takezawa from Osaka University, and I'll talk about our research, material source reproduction, and perceptual deformation with projection mapping for car design. And this research is a collaboration with the Mazda Motor Corporation. Industrial design requires lots of time and cost, and many VR and AR applications have been researched to overcome it. However, some devices using these AR/VR systems have critical drawbacks to apply to the industrial design. In systems with HMD, for example, the user have to wear the display on their head, which gives them the uncomfortableness or narrow FOV. Systems with the IPD don't have sufficient depth expressions because the surface of the virtual object is very different from that of the real surface. VR conflict both in HMD and IPD also deteriorates the simulation experience. Hence, we employed projection mapping or SAR technology for industrial design. By projecting depth cues such as perspective or shading, it realizes perceptual deformation, where the user perceives the deformation without any physical changes onto the mockup projection target. It also altered the surface properties with texture mapping, as you can see on the bottom right figure. And because the shape of the projection target and the virtual object are very close, projection mapping doesn't suffer from the VA conflict as much as HMD or IPD. Our research goal is to boost industrial design in RE processes by introducing projection mapping system. We also aim to obtain practical knowledge in industrial design using the system mounted by the users. Active shutter glasses were synchronized with a 4K projector to realize stereoscopic projection. I'll talk about a little bit about the projection method. The monoscopic projection is a normal projection, as now the projector project here. The same image is conveyed to the both eyes. And on the other hand, in the stereoscopic projection, it utilizes binocular disparities. The projector tempo sequentially projects two images onto the mockup, and each projected image are conveyed to the each eye, the different eyes, using the active shutter glasses that is synchronized with the projector. We hypothesized that the stereoscopic projection would be more effective to induce the perceptual deformations because it utilizes the additional psychological depth cue, which is binocular disparity. Again, our research objectives are to evaluate the usability of the projection mapping and clarify the relationships of the physical and subjective parameters. We conducted two experiments in terms of shape design and material design. First, I will talk about the experiment about the perceptual deformation for shape design. The objectives of these experiments are to evaluate usability of the system for shape design and to investigate the factors to induce the perceptual deformation. We employed the method of adjustment to find quantitatively how much deformation subject perceived as a real deformation. We call it maximum DPD, which stands for degree of the perceptual deformation, perceived deformations in this presentation. Subjects use keyboard to find out the maximum DPD that they perceive as a real deformation. They do it for the both upward and downward deformation respectively. We tested two types of deformations, local deformations and global deformations. In local deformations, only a part of the dashboard is deformed, assuming the local deformations are for the decorations of the dashboard or the character lines. There are two types of local deformations. Gaussian deformation, in the upper left figure, uses Gaussian distribution to realize smooth deformations, while cubic deformation is a cuboid to realize a sharp deformation. The size of the deformation is fixed to the 10 times 15 centimeters, and subject adjusts the height. In global deformation, the whole dashboard is deformed, assuming the height and curvature design. It uses a Bezier curve to parameterize the mockup's cross-section, as you see on that bottom left figure. And subjects adjust the height of the control point. As you can see on the bottom, it's a bit hard to see, but at the bottom right movie shows how the global deformation moves. Because we are also interested in the inferences by the vision, local deformation occurs either in the dashboard center or dashboard right, as you can see on the bottom right figure. And subjects look at either dashboard center, dashboard right, or front. For the analysis, we summarize the deformation place and the looking point as vision, which are central vision and peripheral vision. We also tested both monoscopic projection and stereoscopic projection. And this is the result. And for the local deformation, although there's a subtle differences in the cubic deformation, as you can see in the figure, right up figure, we didn't confirm any main effects of the tested factors. The average maximum DPD is 7.04 centimeter and minus 40 centimeters for upward and downward deformation respectively. And the average DPD is big enough to assume that the system can be useful for the local shape design. Because we didn't confirm any main effects of the projection method, which is monoscopic projection and the stereoscopic projection, we can conclude that the stereoscopic projection is not always necessary to induce the perceptual deformation, especially in case of texture applied. We actually conducted another preliminary experiment where we didn't use texture, and the result of the maximum DPD was much smaller, which was around 1 centimeter upward and downward respectively. And taking that into account and this result, we can assume that the texture plays a very important role to induce the perceptual deformation. And next, I'll talk about the next experiment about the material surface reproduction. We investigated the usability of the systems for the material design and relationships between subjective impression and physical parameters. Subject answered the questionnaire with a 7-point Richter scale about overall subject impression, which is denoted in the yellow areas in the figure, and material surface impression, that is also denoted in the blue area. Overall expression includes both shape and the dashboard, and the surface impressions includes only material surface for the evaluation. And material parameters consist of 2 parameters, one of which is specular parameter, SP, and the roughness parameter, RP, which we designed based on the united surface specular model. They take the either value of high or low. The picture shows how the material look differently with the different parameter values in computer graphics. We prepared 3 types of deformation for the experiment: mockup, sharp deformation, and smooth deformation, as you see on the figure. And this is the result of the projection. This is the example for the smooth deformation. And as you can see, you can perceive the deformation, and you might have the different impressions on the different parameters. And that's the movie about it. So you can easily change the parameters of the dashboard rather, and you might have the different impressions, and you can also change the shape. And because the viewpoint is tracked, if the user moves their head, it's still rendered. The viewpoint dependent rendering can be realized, so they don't have any correspondences. So this is the result. So as a result, we confirmed the main effect of RP. That is, in terms of glossiness, roughness, specularity, and saliency, higher RP leads to higher score. This means a single custom parameter can change the subjective impression, which also implies that the well-designed material parameters can reproduce the material surface with the desired impressions. We also confirmed the tendency of the main effects of the projection method in terms of translucency. That is, stereoscopic projection increases translucency compared with the monoscopic projection. So if we assume that designers want to reproduce the material surface just like how it looks on the display, then because the stereoscopic projection gives some effect, monoscopic projection is more suitable in terms of material reproduction. And this is the conclusion. From the first experiment, we confirmed the usability of the system for the shape design. In order to induce the perceptual deformation, texture plays an important role, and the stereoscopic projection is not always necessary in case of the texture applied. From the second experiment, the results showed that a single parameter can change the subjective impressions. This implies that well-designed parameters can manipulate the desired impressions. We also confirmed that the monoscopic projection is more suitable to reproduce the material surface. And this is the summary of this research. Thank you for listening.
Questions?
Hi, thank you for the talk. Adrian Hopper from Karlsruhe Institute of Technology. I feel your research goes only into the visualization of the surface, but I guess it would be nice if you could also touch it and maybe feel a different surface or so. What are your ideas on how could you achieve this? Because maybe in virtual reality you could have like redirected touch, where you could move the real hand and achieve this effect, but how would you go for that in a real world with your projection?
Thanks for the questions. That's a really important and interesting questions, actually, because as you pointed out, the haptic feedback also gives very huge impact of how the people feel about the material. So one of the possible, it's also the future work, and one of the possible solutions could be that because we now quantitatively evaluate how people perceive the perceptual deformations, right? So while the users don't perceive the deformations, we can still deform virtually, but the virtual surface is, you can gradually deform the surface until the virtual surface is the same with the actual surface. Then you can touch the actual surface as well. Then you can just put some other material samples. Then you can just, it gives the kind of haptic feedback. Then that might kind of solutions.
Okay, great idea. Thanks.
Are there any further questions? So I have one regarding how strongly experts were involved in this. So finally, this seems to be addressed to real car designer. Yep. So in how far they were just involved in the development or in the evaluation?
Actually, for the evaluation, none of the designer hasn't been involved yet. But we are now working with the actual car company, and we've built a system like Mazda. So we have built a system, and we are now exporting the system to the company. So from now, the company is going to use the system, and actual designer or engineer will be involved. Yeah.
Great, thank you very much. So let's thank the speaker again.